It's often useful to be able to scale a line and make it longer or shorter. It turns out it's really easy to do this. An earlier video talked about how to scale an arrow, and the process that we'll see here is the same. It's just a different point of view. When we discussed arrows, we thought of the thing that we were working with as an arrow with its tail at the origin, or 0, 0, and its arrowhead at some point. Now, we'll think more generally of a line, where one of the endpoints is at the origin. I'll show you the technique. Let's begin just by looking at the x-axis. The big black circle is the origin, and we're traveling to the right along x. Now suppose I have a point somewhere on this axis. Let's say it's at a distance x from the origin. I can draw a line from the origin to this point. Now suppose I want to make that line twice as big. I can just draw the line from the origin to the point at 2 times x. That line will be twice as long as the original line. What if I want to draw a line 3 times longer than the original line? Well, I'll just draw it from the origin to 3 times x. Now suppose I want to take the original line from 0 to x and make it half as long. I only need to draw a line from the origin to the point at x over 2. Well, in general, we can scale the length of the line from 0 to x up or down just by multiplying the value of x by some number. It can be any number we like. It can be between 1 and 2, between 2 and 3. It can be any value we want to give it. There are 2 ways to think about this. One is, think about a line from the origin to the point x, and we can use this technique to make that line longer or shorter. The other way is to forget about the line and just think about the point. As we multiply the value of the point by some number, we're moving that point along the x-axis, in effect moving it towards or away from the origin. The x-axis is a nice special case, but let's suppose that we're looking at a line in any arbitrary direction. You can see that the second point out is still surrounded by a heavy black outline. That's our original point, and the line from the origin to that is our original line. To find the lengths of any of the other lines from the origin to any of the other points, we follow the very same procedure. So let's find the coordinates of the heavily circled point. Because I've drawn each of these points directly above their corresponding point on the x-axis, the x-coordinate of that point is x, and its y value is y, just some value, it doesn't matter what it is. So that point is at xy. Where is the point that is twice as far from the origin as xy? It's at 2 times x, 2 times y. We multiply both x and y by the same number. That's the key. That's the whole thing. As long as you multiply x and y by the same value, you will always get points along the line. If you multiply them both by 2, you get a point that is twice as far from the origin. Suppose we want the point that is 3 times further from the origin. That's just 3 times x, 3 times y. Suppose we want the point that is halfway between the origin and xy. That's just x over 2, y over 2. I'm multiplying both x and y by a half. In general, if you want to change the length of the line from 0 to xy by a factor a, just multiply x and y by a. If you do this, the points that you get back from a times x, a times y will always lie along the heavy line I'm showing here, from the origin through xy. So you can either just draw the scaled point, or you can draw the line from the origin to the scaled point, in which case you're drawing a scaled line. Here's an example of this idea in action. Near the upper left, I'm drawing a heavy black circle, and down and to the right, I'm drawing a heavy black line. That line ends in an orange circle. That orange circle is the location of the point xy, where both values are being multiplied by 1. The orange circles represent points that are at 1, 2, 3, minus 1, minus 2, minus 3. The little green circles represent points at other fractions. If I move these things around, you'll notice, for example, that the point at point 5 is always halfway between the origin and the point at 1. And if I squeeze things together, tell you what, I'll make the font smaller so we can squeeze more numbers in there. You can see that we still have these intermediate points always equally spaced along the line from the origin to the point that I'm moving around. So I'll tell you what, if I put more of those points in there, again, I'll make the font smaller, you can see that they're still evenly spaced. I can find all the points along this line just by taking the values of x and y and multiplying them by the number I'm showing. So again, looking in the upper left, if I want a point that is not along the line from the origin to xy, but is in the other direction, I just multiply the x and y values by negative numbers. If I multiply by minus 0.1, I get 1/10 of the way. If I multiply by minus 0.2, I get 2/10 of the way. If I multiply by minus 1, I'm an equal distance away from the origin as xy, but in the opposite direction. So this is all it takes to scale a line. Just multiply the x and y values by the same number. If that number is positive and bigger than 1, you're pushing the point away from the origin. If that number is between 0 and 1, you're pulling it towards the origin. And if that number is negative, you're pushing it away from the origin in the opposite direction. You can scale a line to any length you want using this technique.